Hi, welcome to clickmyproject.com. Title of our project is SOAP Processing, Performance and Enhancement. The web service technology provides a comprehensive solution for representing, discovering and invoking services in a wide variety of environments, including service-oriented architecture and grid computing systems. At the core of WS technology lie a number of XML-based standards such as Simple Object Access Protocol that have successfully ensured WS extensibility, transparency and interoperability. Nonetheless, there is increasing demand to enhance WS performance, which is severely impaired by XML's verbosity. SOAP communications produce considerable network traffic, making them unfit for distributed, loosely coupled and heterogeneous computing environments such as open internet. Also, they introduce higher latency processing delays than other technologies like Java, RMI and Kava. WS research has recently focused on SOAP performance enhancement. Many approaches build on observation that SOAP message in exchange usually involves highly similar message. Those created by the same implementation usually have the same structure, and those sent from server to multiple clients tend to show similarities in structures and content. Similarity evaluations and the differential encoding have thus emerged as SOAP performance enhancement techniques. The main idea is to identify the common parts of SOAP message is to produce this only once, avoiding the large amount of overhead. Other approaches investigate non-traditional procedures architectures including macro and micro level parallel processing solutions, so as to further increase the processing rates of SOAP or XML software toolkit. The survey paper provides a concise yet comprehensive review of the research effort aimed at SOAP performance enhancement. A unified view of the problem is provided, covering almost every phase of SOAP processing, ranging over message parsing, serialization, deserialization, compression, multicasting, security evaluation and data or instruction level processing. Let's see the data flow diagram of our project. Client and server going to communicate with each other by using the SOAP message. So client sends the SOAP request message to the server. In client side, differential serialization is done on the SOAP request message, and it is passed to the client. It passed to the server, and in server side, differential parsing is done on the SOAP request. In this, the unnecessary codes and tags are eliminated. In differential deserialization part, the original message is retrieved and SOAP request message is sent to the server, and server should response for the client request. So SOAP sends the response message. SOAP response message is deserialized by deserialization part, and differential parsing is done on the client side. In this, unnecessary codes and tags are eliminated and original message is retrieved in differential serialization part. Then original SOAP response message is retrieved and it sends to the client request. So this is the data flow diagram of our project. Let's see the demo of our project. In this project we have two applications. One is act as a server and another one act as a client. So first of all, we have to run the server and client side. So in server side, we have to start the server. So server now is in idle. In client side, client wants to send the request to the server, so it browses the file. And client should give the server IP address 192.168.0.68, and differential serialization is done on the SOAP message, that is, it converted as a XML format, and it sends the request. So request is sent to the server. It checks for the response. Response is not received because server didn't respond to the client. So again client wants to send the same message. So dirty bit is added because same message is sent to the client. Dirty bit is added to this file, and its server IP address is 192.168.0.68, and it differential serialization is done, and it sends again. And in server side, it request is received here, and it processes the message one by one. So the first message is displayed here. So differential parsing is done, that is unnecessary codes and tags are eliminated here, and differential deserialization gives the original message, hi, this is client, it is sent by the client side. And another one message is it has to process, but dirty bit is added, no need to process, and server should respond to the client request. So it browses the file. So it should enter the client IP address 192.168.0.68, and differential serialization is done on the message, and it sends the response. In client side, it checks for the response. Response is received from the server, and view response. Here it load the message. This is sent by the server. Differential parsing is done on the message, and differential deserialization is done. The original message is received. And next part is the encryption part, that is secure transformation. So in client wants to send the application data to the server, so it browses the file, and we have to give the private key, that is 2 3, and encrypt the message. Message is encrypted here. It sends to the server. So data is sending. Yes, it sends successfully. In decryption part, we have to give the same key 1 2 3. Before that, we have to view which is sent by the client and decrypted. The original message is retrieved here. And this is a SOAP compression chart. And multicasting. In multicasting, the different techniques which is used in the SOAP performance. To increase the SOAP performance is viewed here. Thank you.